Dear friends, today we'll be going ahead and saying what do you mean by Amdalh Law. Now, why this law was important? Because Amdalh argument is important, or the law is important in two ways. It provides some perspective of unrealistic high expectation that many programmers have with respect to parallelism. Second, it shows that truly big gains in parallel programming involve changing the application algorithm to reduce the serial bottleneck. So it is basically used with respect to parallelism. First thing you should keep in mind. Second thing, it is also used to reduce the bottleneck. Now, what do you understand by bottleneck? It is used for reducing the unwanted instructions which are present when your program gets executed simultaneously. Now, let us understand. It has the potential speed up by programmer using multiple processors. Now, Amdalh concluded that code needs to be parallel. It should have a parallel. It cannot be used for pipelining. Speed up bound give diminishing returns for more and more processors. If more and more processors are involved, then the speed of execution should be high. It should not be low, which we have seen when we were calculating the speed of processors. We were calculating in the form of the throughput, and it should be task dependent. Server gain by maintaining multiple connections on multiple processors, and data can be split up into the parallel tasks, and these parallel tasks can also be executed simultaneously so that we get the desired output and result. And also the server gain can have multiple processors if these processors are in expression of executing the instructions parallelly. Now let us understand with this small diagram what are the different factors that are affecting. One is core. How many core processors are being attached? What is the speed that is being attached to the processor and how they are getting executed? And how will you calculate if your core is 1 and speed factor is 1? So the execution is taking place sequentially, potentially on n number of parallel processors, and again the output is in the form of a sequence. Now if your core is 2 and your speed factor is 1.33, how will you calculate this? It is sequential upon the number of cores that have been connected. So 4 in sequential forms and 3 in this case, that is 1.33. Then you have, how will you calculate the speed factor? You have the core as 5, and in this case what we are using right now, we will have 2.5 as the sequence. So when you divide 4 by 2.5, it comes out to be 1.60. Similarly for infinite, it is 4 divided by 2. So when you divide 4 divided by 2, it is 2.0. So Amdalh law for program running on single processor, fraction f code infinitely parallel, and no scheduling is of overhead. So when you're not scheduling overhead, the bottleneck is already been reduced to a very, very large extent. So no execution time is required for the bottleneck. Fraction 1 minus f of code inherently serial. T is the total execution time that is required by the processor for execution on a single processor. And here n is the number of processors that fully exploit parallel portions of the code. Now let us understand how will you speed up time to execute program on single processor and time to execute program on n number of processor. So capital T bracket 1 minus f is the fraction of seconds plus TF divided by T into 1 minus f plus TF upon N. Now it comes out to be 1 divided by 1 minus F plus F divided by N. Conclusion: F may be small parallel processes for little effect. N is greater than infinite, speed up bound by 1 upon 1 minus F. Diminishing returns for more and more processes. Now, if more and more processes are involved when we calculate with this formula, definitely you will have a speed up parallel processing which takes place and which can be overcome simultaneously. Now, look at the Amdal's graphical representation. It states that in ideal case, there is a linear speed up. In upper bound case, where you have the blue line, it gets parallelly up and then a curve is being established and it goes parallelly. So it is called as Amdalh law. And in practical curve, it declines. The speed up versus number of processors are being used for Amdalh law. So it has the n number of processors which are connected with the speed up processor. So on the x digit you have n processors and on the y digit you have 1 upon 1 minus f. So this is how, when you're calculating the Amdalh law of diminishing return, you should keep in mind how does it will calculate. So you should remember that there will be 3 cases: ideal case, upper bound case, and practical case. And this is how it works with the number of processors and the number of speed up factors. Now, why processor and speed up factors are important? Now, why processors and speed up? Because you need to calculate the speed of the processor, and in Amdalh law, the speed has been calculated with respect to parallel computing. Now, this law also states that the output attribute of an individual unit of input diminishes with the additional unit of input, which is termed as your diminishing returns on investment.